NASA is sending robots to build its Moonbase before a single human ever sets foot there. Everything we assumed about lunar colonization, astronauts arriving first, planting flags, setting up camp is wrong. The real plan inverts the entire sequence. Robots go first, and if it works, it changes how humanity reaches every world beyond this one.
It's amazing to me how you accumulate data, and the data becomes this incredible barrier to entry, this incredible asset.
The one thing that's important here is that once one robot learns how to do a task.
In the next 11 minutes, you will find out exactly what NASA is building, why no human can go first, and what happens when the robots fail. The plan calls for nearly 80 launches and 75 robotic landers before a single permanent human crew arrives. And the part almost no one is talking about, the power source that makes all of it possible or kills the entire mission. NASA's Moonbase plan is real. It has a budget, it has a contractor list, and it has a sequence that almost no one predicted. But the question nobody has answered yet is this: can robots actually construct a structure that humans can survive in for years, and what happens when one breaks down 250,000 miles from home? That is what this video is about. On March 24th, 2026, NASA Administrator Jared Isaacman stood before reporters and made an announcement nobody expected. NASA was scrapping the Lunar Gateway, the orbital space station that had been the centerpiece of Artemis program, and replacing it with something far more ambitious, a permanent base on the surface, built by robots first. This was not a vague promise or a concept slide. Isaacman laid out a phased plan backed by real money. $20 billion in initial investment, nearly 80 launches, 75 landers, 10 moon buggies, and 1 nuclear reactor. This is not a flag-planting mission. This is a construction project. But why robots? Why not send humans first? The answer is brutal. The lunar surface is one of the most hostile environments in the solar system. Temperatures swing from 127 degrees Celsius in sunlight to negative 173 in shadow within the same location, within the same day. Micrometeorites strike constantly with no atmosphere to slow them, and radiation from the sun hits the surface without any magnetic shield. You cannot land humans there with nothing waiting for them. There is nothing to arrive to. The robots go first because they can survive what humans cannot. They work continuously through the 354-hour lunar night. They do not need food, oxygen, or pressurized suits, and they can begin building before any astronaut risks their life. But here is the open question. Here is what nobody has ever tested at this scale. Can autonomous robotic systems actually build a sealed, pressurized, radiation-hardened habitat on the moon? The technology has been designed. Components have been tested in Earth labs. But no one has ever built a moon base. No one has ever done this before. This is the part almost nobody knows about. If this is the kind of deep technical story you want, subscribe before we go deeper. Now let's look at what those 75 landers are actually carrying. The 80 launch, 75 lander number sounds staggering, but when you break it down, it makes sense. According to Scientific American's Inside Report, the launches are phased across a decade. The first wave is not habitat modules or sleeping quarters. The first wave is infrastructure, power units, communication relays, site preparation equipment. NASA is not shipping astronaut bunks in the first cargo run. They are sending foundations. The early robot crews, yes, crews are autonomous rovers designed to survey the landing zone, grade terrain, and begin installing the framework that everything else attaches to. This is where the commercial partners arrive. Jeff Bezos's Blue Origin has already secured contracts for lunar landers. SpaceX, led by Elon Musk, is the primary heavy lift provider. Musk's public reaction to Isaacman's announcement was 3 words: "This will be awesome!" And Musk has a direct financial stake in saying that. SpaceX just filed IPO documents targeting a valuation between $1.75 trillion and $2 trillion. Those documents explicitly name lunar operations as a core business line. But here is where the plan gets strange. NASA is not sending robots that just dig and haul. They are sending machines designed to act as construction workers, surveyors, utility installers, and quality inspectors all simultaneously. The technical name for this is multi-robot task allocation. It has never been deployed in a real construction environment on another world. A 2024 research paper by Jeffrey Lee, Joe Yelderman, and Gerald Cleaver laid out exactly how complex this is. A self-sustaining moon base needs water management, power cycling, atmospheric control, and food production systems all integrated from day one. The robots have to build a system, not just a structure. So what powers all of it? This is the nuclear reactor, and it is the most underreported part of the entire Moonbase plan. Solar panels on the moon face a problem that cannot be designed around. The lunar night lasts 354 hours, 14 Earth days of total darkness. You cannot run life support on battery backup for 2 full weeks, not at any scale that matters for a permanent crew. So NASA and Rolls-Royce, the British engineering company, have been co-developing a miniature nuclear fission reactor built specifically for the lunar surface. The unit is designed to deliver continuous power regardless of where the sun is. Without it, everything else is decoration. Italy recently signed a formal agreement with NASA to cooperate on the Moonbase project. Canada has formalized its participation in European Space Agency programs tied to the same effort. This is not a unilateral American program. It is the largest international space construction initiative in history, more nations involved than were part of the original International Space Station at launch. But the scientists are pushing back. A live science report published weeks after the announcement included a direct quote that should not be ignored. Researchers said, and this is an exact quote, "We have to be careful not to sell something we don't have." Their concern is specific. Of the commercial lunar landers contracted under recent NASA programs, multiple missions have already failed on descent. The moon is hard to land on. Every failed lander is a delayed component in a construction sequence that has no tolerance for gaps. Ask yourself this: what happens if lander number 34 fails and it is carrying the airlock seal for the primary habitat? Does the human crew wait on Earth for a replacement launch, or do they fly anyway and improvise? These are the exact decisions NASA will face, and the cost uncertainty reflects that. Initial reports quoted $20 billion. Other sources cite $30 billion over the decade. That $10 billion gap is larger than NASA's entire annual budget in some recent years. The cost model is still being written, and if that changed how you see what NASA is actually attempting to subscribe. And what comes next will completely change how you think about whether this moon base gets built on time and what it means for the future of human settlement beyond Earth. Here is the answer to the question we raised in ACT1. Can robots actually build a structure that humans can survive in? The honest answer from the engineering community is probably, but not the way most people imagine. The robots will not build a moon base the way a construction crew builds a building. They will assemble pre-manufactured modules. Think of it as a giant precision Lego system. Every component is designed and stress tested on Earth, compressed for transport, then shipped to the moon. The robots unfold each module, position it, and seal the joints. The critical innovation is in the sealing system. Every joint between modules must be airtight, radiation-resistant, and thermally stable across a temperature range of 300 degrees. Robots can be programmed to execute these connections with exact precision. But the verification step confirming that every single seal actually holds before humans board requires sensors measuring pressure, temperature, and material stress in real time, logged and transmitted back to Earth. Jared Isaacman's team has been most specific about this part. The robots NASA is deploying are not general-purpose machines. They are purpose-built for exactly this task. Seal a joint, test it, log the result, move to the next. They will execute this sequence thousands of times before any human is cleared to board. The failure scenario researchers worry about is not catastrophic collapse. It is cumulative error, a robot that gets joint 999 right and fails on joint 1000. The question is whether the monitoring system catches it before a crew arrives. Based on the phased plan, the answer is yes by design. Humans do not board the moon base until every seal has been independently verified by ground control on Earth. The handover requires a full system sign-off. Nothing is left to assumption, which brings us to the thing that makes this more than a moon story. What NASA is executing here has a formal name in aerospace engineering. It is called pre-positioned infrastructure. You build the destination before you send the people. It is the same logic behind Viking 1 and Viking 2 on Mars. The same logic behind every robotic probe that has ever scouted a location humans later wanted to reach. The difference now is scale. For the first time in the history of space exploration, the robots are not just exploring, they are constructing. And Elon Musk has been explicit about what comes after. SpaceX's stated position is that a sustained lunar base is the direct template for Mars. Every SEAL protocol the robots develop on the moon, every power management system tuned for deep space. every coordination algorithm refined through the Moonbase build. All of it gets applied to the Mars mission. The Moonbase is not the destination. It is the practice run. For the first time in the history of space exploration, we are not sending people somewhere new. We are sending builders to prepare a place where people can actually live. That is a different kind of mission, a harder kind of mission, and if the robots get it right, the next frontier will not be a place humans visit. It will be a place humans call home. Subscribe if you want more stories like this one.